Some of you already wrote the module for sticky notes, but if you didn't, this is the actual audio version. My other one, which already was up to 2 views, so that's amazing. That module, unfortunately, I forgot to press a simple button, and so there was no sound. And to be honest, I think it was actually my best lecture yet. So whatever, it is what it is, right? So let's talk about carbon and nitrogen. And probably out of all the cycles, I think these two are the hardest. So it's really important that you try your best to really understand how these elements flow through the ecosystem. And so, one thing to note when we talk about biogeochemical cycles, we're talking about the cycling of pretty much atoms and molecules. Because remember that they're neither lost nor gained, it's just transferred and cycled throughout the ecosystem in different forms. And so, the most important elements, and you might have learned this in chemistry, are I call it SNOPs. So it's carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And so those are really what we're following with the exception of sulfur. So one thing that you need to make sure that you get down is the difference between a source and a sink. A source is when atoms are leaving a reservoir. And think about the reservoir as like the place where things are being kept. So think about like, Woodcliff Lake Reservoir. I mean, it's huge, right? So it's holding something. So a source is when atoms are leaving. So if water is leaving a reservoir, if nitrogen is leaving its reservoir, if phosphorus is leaving it. Whereas a sink is actually where the atom is being stored. So kind of a sink and a reservoir, you can kind of think of those as the same thing, whereas the source is where is it coming from. So another thing to note, and the biggest thing here, is that the carbon cycle is the movement of atoms and molecules containing the element carbon. And if you remember, carbon is really a great element because it actually has 4 available bonding sites. So therefore, you can find it in many different forms. Remember that if something has carbon in it, it is organic. But we're really going to be looking at how carbon moves between sources and sinks. And so the real main way in which we pretty much are moving carbon through living things is through the process of photosynthesis and cell respiration. You need to make sure that you get these two down. Remember that CO2 gets taken out of the atmosphere through photosynthesis while respiration puts it in. So make sure if you don't know this equation or you don't remember it, that we reestablish it. You write it multiple times, but you should definitely know this. So CO2 plus H2O, so that's our carbon dioxide or water, that's going to yield 1 molecule of glucose and an oxygen. And then respiration, if you look, it's literally the exact opposite process. So one other thing they're going to notice, some of the reservoirs in which carbon compounds occur in, the carbon cycle hold those compounds for long periods of time, while some hold them for relatively short periods of time. So, if we think about fossil fuels, right, there's stored carbon there, and technically they've been there for millions of years. It's just that now we're literally extracting it faster than we can replenish it. And so plant and animal decomposition have led to the storage of carbon over millions of years. So that's really, there's dead plant and animal remains, and they kind of get like further and further put into the earth, and then eventually they become fossil fuels, but it takes millions of years for that to happen. And then if we think about that, there's other things where we can, it happens really fast. So if we think about this, the burning of fossil fuels quickly moves stored carbon into the atmosphere in a form, as we all know, as carbon dioxide. And so this picture does a great job. You can see all the arrows are things that are putting carbon dioxide into the atmosphere. And if you look, there's only one way in which we take it out. So these are all the reservoirs or places that were holding carbon dioxide: atmosphere, land plants, soil and detritus, rocks, fossil fuels, ocean biomass, ocean waters. And so these are places that we want carbon to be, right? We don't want it to be offset into the atmosphere. However, that is what's happening. And so without human disturbance, there's a steady state. So if you look, CO2 ends up getting kept in our soil through all the organisms, and then decomposers release CO2. And so one of the things that's important to note is that we need carbon dioxide, right? It is a way to warm our earth and to help keep the solar radiation and the heat from that here, so our planet's not cold. However, too much of it, you want to think of it as a wool blanket. And so all of that is eventually leading to global warming. So the next thing to note is nitrogen. The nitrogen cycle is probably the hardest out of all of them. There's really two main parts. And so the reason why we need to care though is because nitrogen is the building block of proteins, and pretty much it makes up our DNA and RNA, but we can't get it from the atmosphere even though there's a ton of it there, more than oxygen. So how are we going to actually get nitrogen to our bodies? We need to eat it. And so if we think about that, the movement of nitrogen is different transformations of nitrogen itself. So the nitrogen cycle is the movement of atoms and molecules containing the element nitrogen between sources and sinks. And so the first process is nitrogen fixation. And so this is where you have atmospheric nitrogen, and it's literally getting converted into a usable source of nitrogen. Usually it's ammonia. And then pretty much because of that, there's like these little bacteria that live in the root systems of certain plants, and they're literally taking out the nitrogen and they're turning it into this usable form. And therefore, eventually, it makes it available for uptake from plants, and this that can be synthesized into plant tissue. And remember that the atmosphere is the major reservoir for nitrogen as opposed to carbon cycle, where we saw that there's actually a bunch of them. This is the process of nitrification. So if you look, we pretty much start from ammonia, and then eventually we can turn it into nitrates, and then we can assimilate it into tissue. So you look here, there's a bunch of different ways in which we can actually incorporate it into the tissues of organisms. And so at the center of it all, there's really bacteria. It's on the front end and the back end. Well, I guess there's not really a front and a back because technically it's a cycle, right? But you'll see that there is an arrow putting nitrogen gas back into the atmosphere, and that's also done through special bacteria. So they're going to literally take this one form of nitrogen and they're going to turn it back into nitrogen gas. So make sure you take a look at this this picture, this graphic. It does a great job. Make sure that you understand the difference between fixation and denitrification. Okay, so that's like really important. Those are the two things. Most of the reservoirs in which nitrogen compounds occur in the nitrogen cycle hold these compounds for relatively short periods of time. Just think that nitrogen is not necessarily staying for millions of years in the tissues of plants, right? It's moving pretty quickly. And it makes sense because think about on a daily basis, there's a cow, the cow is eating the grass. Now, the nitrogen that was in that plant is now in the cow, and then who eats the cow? Well, whoever wants to eat meat, if that's what you decide to do. And if you don't eat meat, then you're eating the actual plant. Either way, you're getting nitrogen, and that's what's most important. I hope that you found this to be an exciting adventure. I'm trying to spice up the cycles because they can be a little dry. When we get back to class, we will do a few exercises to try to help you further understand the cycles, but hopefully now you have kind of a foundational working knowledge of the 4 cycles. So I hope all of this was fantastic. This presentation was not as epic as the one I did earlier that had no sound, but it's all good. You now have all of the sticky note lectures available to you. So I hope that you enjoy these last few days of summer. Soak it in. And I look forward to seeing all of you next week to start our epic journey on the boat we like to call apes, right? All right, take care.